Alright, so in this video, we'll be covering the principled BSDF shader. This is one of the most important shaders when it comes to creating any type of material in Blender, as it has so many of the key elements that you'll need to create these complex materials. So we can start by going to the shading tab up here, and we will be presented with our shading workspace. We have our files over here, the UV editor, of course our outliner and properties panels here. So by default, whenever you add in a new material, you will be presented with the principled BSDF and material output node. So whenever you're creating your material, you need to make sure that it's connected to the material output node. Otherwise, your material will just turn out black. So make sure that it's always plugged in. Alongside the surface socket, we have the volume and displacement sockets. Volume refers to any volumetric properties that we want to add to our object. The most common use for the volume socket in the material output node is using the principled volume node. And displacement is a good way of adding in higher detail to your mesh without actually having to add in geometry in edit mode. This means that you can use nodes to dictate the actual shape of your object without having to do any editing or sculpting. But for now, we'll simply be focusing on using the principled BSDF connected to the surface output. So I'll start off with going through the most fundamental parts of the principled BSDF shader, then going through a few more niche values and properties. So the first thing we can start off with is the base color. We've already encountered this in the previous video, but I'll go through it again briefly. We can choose our color by either playing around with the color wheel or by using the RGB, standing for red, green, blue, HSV, standing for hue, saturation, and value, or hex code to systematically dictate the exact color that we want. The next major feature of the principled BSDF node is the metallic slider. This is a mix of a few different properties in our principled BSDF node to achieve a very basic metallic looking material. So if we click and drag on our slider, you can see the appearance of our material start to change. It becomes a bit darker and a bit more reflective, as you can see slight areas of highlights indicating that our material is a bit shiny in some regions. I'll change the color to dark to better emphasize the metallic look of our material. The next property we will look at is roughness. So let me turn down the metallic to 0 so that we can solely be focusing on the roughness slider. So roughness dictates how much light is being reflected off of the material surface. So if we turn roughness all the way down to 0, you can see that we have some of the reflections of our background appearing on our object. However, when we turn roughness all the way to 1, you can see that we don't have any reflections. To further demonstrate, we can go into rendered mode by pressing the shortcut Z on our keyboard and clicking on rendered view. Then if we press Shift A and add in a light and an area light, we can see the effect that the light has on our object. So I'll right click on my cube, and right now our roughness is set to 0, meaning that it won't reflect much of our light. However, if I bring the roughness down to 0, you can see very clearly the shape of our light. This is of course due to our object being very reflective. One thing to note about our sliders is that when we drag it all the way to 1, we can't drag it any further. However, we can also manually input values into our fields. So if I wanted a roughness of 0.15, I can input it like so. I could type 0.8. However, one thing many people don't know is that we can type in values beyond the limit set by our slider. So if I wanted a roughness of 10, you can see that that's actually possible. Although it might not be very realistic, sometimes adding in these values can be just what you want for the type of material that you're trying to make. So I can go back into material preview mode by pressing the Z key and clicking on material preview, and I'll delete the light that we just added in. I'll go back onto my material and then change the roughness back down to 0.5 as originally intended. The next property we will discuss is the emission. So if we go down towards the bottom, you can see that the emission is set to black. This is equivalent of setting your emission strength to 0. So what we can do is click on the black box, bring up the slider, and choose any color we like. So I'll pick blue. And it's somewhat difficult to tell the difference between whether our cube is emitting light or if the color is just blue. So what we can do is go into rendered view once again, and we can play with the emission strength. So as we play with the emission strength, the brighter it shines. And one thing we can do to further see the effects of the emission strength is go to our render properties on the right hand side, so this TV icon here, and enable bloom. If we turn down our world settings, we can see the contrast even better. So playing with the emission strength will have a very noticeable impact in our render. So I'll go back into material preview mode and bring back the strength to 1, and also we can disable bloom. So that's it for the main features of the principled BSDF node. As beginners, you'll be using most often. So we can go into some of the more niche properties. So starting from the top with subsurface. Subsurface, or known by its full term, subsurface scattering, is the effect where light enters through a material, bounces around before leaving. So one example of this in real life, if you hold a bright light up to your finger, there's a good chance that you'll see your finger glow red slightly. This is because the light is penetrating through your skin and hitting your red blood cells before being reflected back out of your skin. This is an example of subsurface scattering in real life. Let's enable it in Blender, but first I just forgot to turn our emission strength to 0, and now we're back to our gray cube. First thing we need to do is turn up our subsurface to something like 8.3. And then once we've turned up our subsurface, we can change the subsurface color. So I'll choose something like orange. And you can see that there's a slight blending effect between our base color of gray and our subsurface color. The more we turn up our subsurface, the more it looks like our subsurface color. This is a very useful property whenever you're making skin or hair or any type of organic material where light can kind of penetrate it, but not fully. Alongside this, we have two more subsurface properties, one being subsurface IOR and the other being subsurface anisotropy. Subsurface IOR just stands for subsurface index of refraction, and this is to do with how much light actually refracts within the material. And the other one, subsurface anisotropy, being the directionality of the subsurface scattering. These are both properties that are only available in cycles. We are currently using the Eevee render engine. We don't need to worry about these two fields. So I'll decrease my subsurface to 0 as we move on to our next value, which is specular. So to better demonstrate what specular is, I'm going to press Shift A and add in a mesh, and we'll add in a UV sphere. Once again, we will just change the segments to 64 and 32 just to make it smoother, and I'll press G, X to bring it to the side, and then press W to shade smooth. Then I'll click on new to add in a new material. So to properly demonstrate the effects of our specular property, what we can do is decrease the roughness of our new material to something like a 0.1 and increase our metallic to something like a 0.4. And then also this works best when you decrease the brightness of your material. So when we increase our specular property, you can see the highlights on the edges of our material a bit better. However, when we decrease the specular, we no longer have those highlights on the rim of our material. This can be a very subtle change, but it can add a lot to your materials, especially if your material is heavy on reflections and how it interacts with light. So the specular tint is a property related to the specular, in which increasing should make our specular reflections tinted towards our base color. We've already covered roughness. The next properties are anisotropic and anisotropic rotation. These are both properties that can only be used in cycles. They're primarily used whenever you're dealing with specular reflection. One example to think of is whenever you look at the bottom of a frying pan. This is very useful. The type of reflections you see are dependent on the angle and the rotation of your viewpoint. So the next property is sheen. Sheen is a special type of reflection best used whenever we're dealing with cloths or fabric, something that we can't really show unless we're using textures. Alongside this also goes for sheen tints. Clear coat is a very useful feature which adds a layer of white shine to your material. So if I just turn down the metallic and the specular to a 0.5 and bring up the roughness a bit more, you can see that we still have a clear coat, almost like a layer of glass shielding our sphere. So if we bring it down, you can see that it becomes less and less shiny on the outside. And clear coat roughness basically determines how shiny our clear coat will be. So if we bring that up, it pretty much looks like we don't even have a clear coat. So the next values, IOR, transmission, and transmission roughness, are all to do with how light passes through an object. IOR stands for index of refraction. Transmission just means how much light can go through this object. So for our transmission shader, we can make a very basic, glass material by turning up the transmission to 1, making sure that all of these properties are set to 0. Actually, subsurface IOR doesn't matter, but it's fine. And then what I can do is go into our options by pressing N key here, which brings up this panel on the right hand side. Go to options and change the blend mode from alpha or from opaque to alpha hash. This is probably the best one to use. So if we go into render mode by pressing the Z key, you'll be able to see our glass shader. However, if we add an object behind it, and let's just add some light to our scene. So I'll just change this to an area light and turn up the power. So as you can see, we have light shining on our object. However, if we scale up our sphere here with the transmission all the way up, we're actually not able to see what's behind our object. So right now, Eevee isn't properly interpreting how light should interact with our transmission. However, to change that, what we can do is go to our render properties panel here and then enable screen space reflections. Go to this tab here and turn on refraction, and that should do absolutely nothing. And make sure to enable screen space reflections in your options here, and now you will kind of be able to see the objects behind your material here. As you can see, this is just due to refraction. We can kind of see our cube, but the light is bending around this sphere. So that's how you make a very basic glass shader. All right, so I guess we can just change that. So bring down, before I move on, transmission roughness is basically similar to clear coat roughness and just regular roughness. This is basically how blurry your material looks, or how much light actually is able to pass through, or how much light is scattered through. So as you can see, the more I turn up the transmission roughness, light is able to penetrate through the sphere, but there is a lot of internal reflections as well. So that makes it a bit more blurry. All right, so I'll just turn down the transmission to 0, and then the final nodes to discuss is the normal, clear coat, normal, and tangent. So normal is something that we will be using in the next video, where we create our metal shader, basically allowing us to control the normals of our base layer, which means that we can fake the way that light interacts with our surface of the material. So what we will be using is bump. So imagine that we have a bumpy surface. Without needing to model anything, we can tell Blender that this part of the material is a bit more wavy or bumpy, or you'll see, but yeah, that's what we typically use normal for. And then for clear coats, normal, and tangents, and it's something that we won't be touching in this series as it's a bit more advanced options. However, clear coats normal is similar to normal, but for clear coats, pretty evidently. However, we can just change the normals, change the bump of our clear coat texture, or clear coat layer, I should say. And then tangent controls the not the normals, but the tangent for our anisotropic layer. Once again, this is something in cycles that we don't need to worry about. But all of these dark blue nodes essentially do the same thing, adding bump, or influencing the pattern of light scatter on your material. Okay, so that is it for the basics of the principled BSDF node. Hopefully you now have a good sense of what this a really useful node does in Blender. So in the next video, we will be making a metal shader, and this metal shader is going to be using mainly the principled BSDF node, along with a few others, to create a really good looking material. So next video will be the metal shader.